Hi everyone, welcome back to my channel. So as I have promised, I will go through this list or let's say syllabus one by one. So currently I'm now on the decision tree. So the lesson of today is a decision tree. So let's just jump to the decision tree. So the decision tree is a supervised learning algorithm used for classification and also it's used for a regression task. But in this example, I'm focusing on classification. So how the decision tree is work? As you can see, it is splitting the data set into smaller subsets based on some features, and also continuous splitting until stopping, let's say, condition is met, or let's say after finishing the data set. So if you have, let's say, a data set like this, for instance, this here, our data set, the attributes are weather, time, and hungry. Let's see if the weather is sun and the time is greater than 30 minutes, let's see, and hungry, yes. So decision, he will take a bus, for instance. And if it's sun and less than 30 minutes and hungry, no, he will try to walk. And this data set, we will try to build the model that we will, let's say, reflect the decision tree, like, for instance, this one here. So, what is the real, let's say, application of the decision tree? So the decision tree could be applied for, let's see, many applications, like loan approval in banking. If you would like to apply for, let's say, credit, so based on your, let's say, income and some other parameters, it will approve, it will give you yes or no. And for instance, this is diagnosis. So for one project I have done with MRI classification. So I have some images, extracting some features from these images, and the final decision is to see if the this build or MRI has a disease or not. Let's see, tumor or not, and many other functions. So why we need to let's say to use a decision tree? It's easy to understand and interpret. I will give you also example and step by step how to construct the decision tree, and also it requires a little data processing and also handling both numerical and categorical. So let me just go dive into the decision trees. For example, this is a decision tree. So how this is, for instance, we select the weather, and it also depends on your data. So how did you, let's say, select this weather? Why not time or why not hungry? This, for instance, as you can see, this is rectangle with blue is the parameter, the attributes. As you can see here, this is 1, 2, 3, and this is the decision, or let's say class label. And these values here, the last one here, is the class label. And these, for instance, these values here are the values of this, for instance, attribute. For instance, whether if it's sun and if it's cloud or if it's rain. So how to select this? Let's see how to choose the root node. So there's two methods. Let's see. It's information gain or Gini index. So this example also focusing on information gain. So let's say, for instance, in the beginning we need to calculate the entropy of the whole data set, of the entire data set. And as you can see here, it's summation of bi log to the base 2 bi, and bi is the portion of the ith class in the dataset. And the information gain is also measure the reduction in entropy after splitting the dataset based on the attribute. And you can see calculating the attribute of the variable for the subset of the dataset and try to let's see, reduce it from the entropy of the whole dataset. So let me just go into the example. It will be very easy for you. So first, let's say calculating the entropy of the entire data set. So this is our data set. It's just for simplicity. So it depends on your data set. But let's say here I have decisions. I mean, this is the class label. I have path, 4 instances, 1, 2, 3, 4, and the walk is 2. And calculating the entropy of this data set, it will be minus this B. It's proportional, as I said, is not the probability, but the proportional of the this class to the this data set. For instance, here I have 4 of 6. So it will be 4 divided by 6, log 2, and this is also the same, plus, now I have for the second the second class, it will be 2, 2 of 6 let's see, walk. And this is the entropy class of this entire data set. And if you have any other class, let's see, for instance, I have only here 2 classes. And in your case, if you have 3, 4, 5 classes, you will add it plus 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 until getting the calculating the entropy for every class. Now let's see, after calculating the entropy, now I would like to select what is the best feature, let's see, to be in the root. As you can see, for instance, like this here. What is the features? This or this or this in our case. Now this is, we need to calculate the entropy for each attribute. So for instance, I will start with weather. And as you can see, weather, it has 2 sun. And one sun is bus and one sun is walk. So I will try also to calculate the entropy of this, of the sun. It's one of the 2 instances are bus, and one of the instances of the 2, let's see, as is a walk. And this is the entropy of, let's see, of the sun. And now we will go to the cloud. Cloud, we have 2 as well. It's cloud, bus, and walk. It will be also the same. And now for the rain, it has 2 instances, but all of these 2 instances, let's see, belong to the bus class. So you can see the entropy will be 0. Now we need to multiply all and sum all of these and see the entropy of the weather itself. So this is the 2 divided by 6, because we have here the first entropy, the first let's see, instance of the walk. It's 2, and here 2, and here 2. And this is multiplied by the entropy. For instance, here is entropy 0, and here is 1, and here is 1. And this is, let's see, the entropy of this data set with respect to this feature. Let's see whether. And the information gain, we will try to reduce, subtract the information, the entropy of the weather attribute from the old, let's say, the general, or the entropy of the whole of the classes, as we can calculate it here. Now we will do it for the time. It's exactly the same. So for instance, greater than 30, there are three instances, 1, 2, and 3. And all of these, let's see if you can see, the decision is taken to take a bus. And you can see the entropy is 0. And less than 30, it's also 3, but maybe walk and bus. And also the same as the entropy, the previous one. And if it's not, let's see, if I'm fast, you can just pause the video and try to calculate it yourself. And be sure this is already calculated exactly correctly 100%, hopefully. And now we will go to the hungry class, the hungry attribute. Calculating the same, yes, as you can see here, yes. So yes, it's belong all the yes instances. The class label is bus. For instance, yes is bus, bus, bus. And calculating the entropy and also information gain. So now, as you can see here, after selecting how to select the attribute now, based on the information gain. For instance, here we have the information, the weather is 0.2, 0.4, and 0.54. And as you can see, all of these are the same. So you have the possibility to choose which one is the should choose some byte, for instance. Now I will try to select, let's say, the time. And from the time, you can see, as we have seen, the time greater than 30, all the instances have the bus. So you don't need to split the dataset again. So just take this 30, greater than 30, and it will take the bus, for instance. Now we have 2 options in time, greater than 30 and less than 30. And if you have many others, it will be. So now, with respect to this one here, as you can see, time with time, less than 30, less than 30, I will take this, it's walk and bus. For this, I can't see it. For instance, I just put the class label here as the bus, because as you can see here, greater than 30, bus, greater than 30, bus, greater than 30, then bus. So there's no other options. So I will just assign the bus class to this. So, and for this class less than 30, I have to split the data set and just take this only the less than 30 data, 30 less than 30. As you can see here, I remove all the others that are relevant for me, and I just take the less than 30. Now I will try to go through this steps as from the beginning, calculating the entropy, calculating the information for each attribute, and etc. As you can see, it's almost the same, and you can see calculating the information gain for this, and you will also try to see what is the maximum, let's say, information gain. And you can select, for instance, less than 30, then you will you have to select one of these attributes, and etc. So this is, let's see, a simple explanation. Continue until finishing the dataset. So now, what is the advantage of? Did I miss something here? No. The advantage of the decision tree is easy to interpret, handle categorical and numerical data, and can capture nonlinear relationship. But what is the disadvantage? It's somehow it's prone to overfitting. What is the overfitting? So the overfitting, our model is working on the training data set perfectly. Let's see with no, let's see perfect. And when I try to test the model, it's working worse. So this called an overfitting, and overfitting could be let's say removed or over, reduced by regularization. So I have uploaded also some videos on the regularization for regarding the linear regression, and it's almost the same here. And if there's any changes in a small data set, in the data set, it will, you have to, the tree will be changed. And also it depends on the features in the data set. So I have also implemented the decision tree. Let me just share my code here. So this example here, I have seen an error here, huh? Okay. The item feature. And for this Python code, I have implemented without any, let's see, any packages. It's a pure Python. As you can see, entropy function, calculating the information gain, and finding the best features is only the feature. And here's a building the trees. Now, as you can also see, if you go to, no, this is a decision tree. Sorry, decision tree. So if you see that this is the implementation, pure implementation, just to show you how the everything is working, and also you can run this and debug if you see what are the values, and to make it, let's see, clear that you understand everything. It might be, let's see, if you are a student in the uni, they might give you a small data set to calculate, let's say, to construct a tree. So this will help you. And for the, let's see, if you have a big data set, you will try to load the data set here. This is with scikit-learn. You will try to load your data set. We will see in the coming videos how to load data and how to pre-processing the data in the real projects. Let's see. And here you can see I have imported decision tree classifier, and you see everything is already implemented in this. Here is splitting the data. This is the decision tree classifier, and here you see fit, predict, and you can calculate the accuracy. And yeah, that's it for today. And I think I have I have covered everything for regarding the decision tree. And as you can see here, this indeed took a lot of time for me to prepare this tutorial. And so if you like it, please subscribe and like this video. And if, of course, if you have any question, drop it down in the comment below. I will go back and I will answer it. Thanks for watching and see you next time.